Hello. This is the periodic table. There are 118 elements in the periodic table, and as of this video, researchers are focusing on a 119th one. We will talk about the periodic table by pointing out the elements in each row. First of all, we have hydrogen and helium in row 1. Hydrogen is the most common element in the universe. It is the most common element in molecular clouds, sprinkled with a lot of helium. Hydrogen needs to bond with one atom before it can't bond anymore. Helium is a noble gas. It is the element with the smallest atomic diameter, and is what stars first fuse when they reach their giant stage. Now back to the ennoble gas part. That means helium can't bond with any other atoms. Just like hydrogen's nucleus is usually a proton, helium's nucleus is usually another notable subatomic particle, an alpha particle. Now on to row 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Let's go backwards this time. Neon is a noble gas, just like helium. Its plasma is used in neon lighting signs. Fluorine is our first halogen. Halogens need one extra electron, which means one more atom. They're just like hydrogen, but way more aggressive. In fact, fluorine is the most reactive, corrosive element in the whole periodic table, so stay away. It can even eat through some oxygen mask materials. Now on to oxygen. Although oxygen is necessary for bodily processes, it is oxidizing and is basically fire fuel. It's the reason matches burn, whether strike on box or strike anywhere. Nitrogen is most famous in its liquid form, where it is used in cryogenics. It is the most common gas in Earth's atmosphere, and it is the base of plant nutrients such as ammonia. Carbon is usually present in a hexagonal lattice, graphite. In a single atom-thick structure, it is called graphene. At high pressures and temperatures, carbon turns into its diamond allotrope. Carbon nanotubes are often used for stable object parts, electronics, electromagnetic shields, and vantablack. Boron is a brown element that is used as a strengthener, a deoxidizer, grain refiner, and conductivity adjuster. Beryllium, when held against americium, polonium, and two other elements, it becomes a neutron source. Lithium is an alkali metal, just like beryllium is an alkaline earth metal. Lithium salts, i.e. LiCl, are often used in lithium-ion batteries to provide electricity. Just like the other alkali and alkaline earth metals, when you drop it in water it explodes. The third row is similar. Let's go backwards again. Here's a guessing game. In your mind, answer, is argon a halogen, a noble gas, or a nonmetal like hydrogen? If you guessed noble gas, you are right. Argon is usually used in food packaging, e.g. the salad boxes you see at the grocery store, and ampoules containing samples for element collectors, because it is an inert gas and prevents food from spoiling, or metals like copper from tarnishing. Chlorine is another halogen. It isn't as strong as fluorine, but still pretty strong. It is the base component of HCl, hydrochloric acid, which is an industrial reagent, chemical, and is also found in the human stomach, combined with digestive enzymes, to dissolve food and harness its nutrients. Sulfur is a flammable nonmetal. When it burns, it releases toxic SO2, sulfur dioxide gas. It is naturally found in FeS2, iron pyrite. There are some studies that pyrite might house gold in gold-rich areas, although in other areas, it is treated as a non-useful find. Phosphorus is also flammable like sulfur, but not as much. It comes in three main allotropes. Red, found in matches; white, used to be in matches but replaced due to its toxicity; and black. There are still others like violet. Silicon is often used in IC chip as monocrystalline silicon. Silicon dioxide, SiO2, quartz, is a piezoelectric material, meaning it changes shape when electricity is applied to it and creates electricity when it is compressed. Hitting a quartz crystal with a hammer will produce red-orange sparks of electricity. Aluminum is often used as aluminum foil, aka tin foil, to keep food warm. It is also used in electronics because it is conductive. Magnesium is an alkaline earth metal, but it isn't toxic compared to beryllium. Magnesium, when burnt, releases bright white flames that release UV radiation. Sodium is commonly found in table salt, sodium chloride, NaCl. It is an alkali metal. Just like the other alkali and alkaline earth metals, It is an ionic bonder. See my video, Ionic Bonding and Electrolysis, Part 1 for more about that. It will explode when dropped in water due to its high reactivity like lithium. The fourth row has way more elements, so I'll speed run here. Potassium and calcium explode when placed in water. Elements in column 1 except for hydrogen are alkali metals, and column 2 are alkaline earth. Elements 21 to 30, scandium, zinc, are the transition metals in row 4. Iron is magnetic. Cobalt is used in cobalt blue paint. Copper is used in electronics and pennies. Zinc is used for the core of pennies since 1983 because of the rising prices of copper, a semi-precious metal. Elements 31 to 36, gallium, krypton, are all the other stuff. Gallium is used in electronics as gallium-indium droplets. Germanium is used in diodes. Bromine is a liquid at room temperature and is just as poisonous as fluorine. Arsenic is poisonous to almost all forms of complex life. Krypton is a noble gas, and one of its isotopes is one of the fission products of uranium-236, produced by hitting U-235 with a neutron. Row 5 contains our first radioactive element, technetium. Silver, also in row 5, is our first precious metal. It is the best electrical conductor and, if you polish it really well, the best mirror in theory. Silver is also used in electronics due to its high conductivity and in antimicrobial PLA. Palladium is a precious metal that commands high prices in electronics and engineering, similar to platinum. Molybdenum is used in electronics and in traces, a nutrient for the human body. Cadmium is toxic and used in cadmium red paint. Iodine compounds are used as medicine, and xenon is experimentally used as an anesthetic. Side note, try getting ampoules of noble gases and holding them next to a low-voltage Tesla coil. It'll look cool. Just no radon. Row 6 is even longer than row 5. It is so long that part of it was broken off to form the lanthanides, named after lanthanum, element 56, the first element in the subgroup. Let's start with the lanthanides. Europium is used to render the color red in most pixels. Terbium is used to make medical X-ray devices safer by reducing the amount and intensity of X-rays needed to produce an analyzable image. Erbium, on the other hand, is often used at FTTH, fiber to the home, applications to keep routers connected. Samarium is found in headphones. Promethium is radioactive and used in research and atomic batteries, and lanthanum is used to enhance image quality in cameras. Now on to the rest of row 6. Barium and barium salts are used to give a green color in most fireworks. Boron also does the job. Gold, as the second best conductor of electrons, is used in electronics. It is also a metal that is invested on and used in jewelry. Tungsten is a really resistant and dense metal. Tungsten filament used to be used in light bulbs, but were not very efficient. It is used in fluorescent light, and it makes very strong cutting and drilling tools, used in applications from mining to dentistry. Mercury used to be used in thermometers and barometers, but is mostly phased out due to its toxicity. Lead is used in lead bullets. In military applications, bismuth is now used because it is non-toxic. Bismuth is observationally stable, meaning that calculations expect it to be radioactive, but this decay has never been observed. Platinum is used in electronics and jewelry and is just as or more valuable than gold itself. Radon leads to lung cancer and is often found in the basements of houses. Astatine is so radioactive that it will vaporize itself and is only used for research. It is experimentally used in cancer treatment. Polonium is used in brushes that pick up dust from photographic film as an alpha source and a neutron source when kept next to beryllium foil. Cesium is used to generate electricity from fission and in atomic clocks. Row 7 is an interesting row because all of the elements in this row are radioactive, compared with 4 for row 6, 1 for row 5, and none for rows 1 to 3. Let's start with the actinides. Uranium and plutonium are used in fission plants and weapons. Americium is used in most smoke detectors to, well, detect smoke. Thorium is experimentally used in fission technology. Actinium is used as a neutron source, of course, with beryllium and in radiation cancer therapy. Curium is experimentally used in cancer treatment, but it is mostly used in research. Elements 97 to 103, berkelium lawrencium, are used in research for superheavy elements. Now on to the rest of row 7. Radium used to be the material that watch dials were made from, around 100 to 70 years before the making of this video. The radium sulfate trace had fluorescent paint painted on it that glowed green when irradiated by the radium, hence the term radium green. As of the making of this video, the paint has long since chipped off, but the watch dials are still radioactive. Francium is used only in scientific research and is potentially more reactive than cesium. Elements 104 to 118, rutherfordium oganesson, are the superheavy atoms. They are only used for research in superheavy elements. And that was the periodic table for starters by Smart Budgie Science. Stay safe and bye.